All right, so today we're going to do part one of parent functions. We're going to talk about what a parent function is and be able to identify the attributes of each parent function. So the first function that we're going to start off with and start off doing is a constant. Turn this stuff away. Okay, so a constant, the equation for a constant is going to be y is equal to a number. That number can change just depending on whatever it is, but it's always going to be y is equal a number. So the only variable you're going to see is y, and then you will see some number. Okay, if you look at your graph, your constant graph is always going to be a horizontal line because you're only representing the y values, and your y never changes. Okay, so your domain, when you go left to right, is all real numbers, or we're going to go negative infinity to positive infinity. And your range never changes. So your range is going to be at whatever this number is. So you only have one element in your range, and that would be what this number is. If we were talking about this specific graph that is on this slide, then my range would be at just 2. All right. If you look at the graph, it does not touch the x-axis, so there is no x-intercepts, and your y-intercept is going to be a point at 0, 2. There's no jumps within a graph, so this does not have an asymptote. Because it stays in one place, there is no max or min, so there's no high point or low point. And because the y-axis divides this graph, its symmetry is reflectional. And then there isn't a inverse. It's an NA. NA. So that's constant. Okay, the next is what we have is a linear. So the parent function for a linear is y is equal to x. You have a graph that is going through the origin where you have a slope of 1. So the slope is 1 and your y-intercept is going to be 0. That's how you know you're dealing with the parent function. Your domain, when you go left to right, you are going from infinity to infinity. So that's negative infinity to positive infinity. Looks like an 8. Should be an infinity sign. Oh, come on, work with me. Sometimes this gives, haven't used as much, so sometimes it gives me issues. All right, your range is going to go from low to high. So if you go low to high, you're still going through arrows. So if I go low, still continues. If I go high, still continues. So negative infinity to infinity. Your x-intercept is going to be 0, 0 because it goes through the origin. And your y-intercept is also going to be at 0, 0 because it goes through the origin. You look at the graph, there is no jumps. There's no curves that are leveling. So this graph does not have an asymptote. Because it continues, there's no max, nor is there a minimum. And your symmetry is going to be rotational. If you turn this graph or the paper upside down, you'll notice that the graph does not change. Okay, and then the inverse of this function is just itself, and it's actually when we get further down the road, this line right here is going to be our kind of guide to help us determine inverses. All right, moving on to the next one. So here we have quadratics. The parent function for a quadratic is y is equal to x squared. Okay, so you're taking your x value and squaring it. You have a U-shaped graph, and that U-shaped graph is called a parabola. Parabola. The domain, if you go left, you're going through arrows. When you go right, you're going through arrows. So that's negative infinity to positive infinity. Okay, if you're looking at your range is going to be low to high. So what's the lowest point here? The lowest point is at 0. And the highest point, there isn't one. It continues. So your range goes from 0 to infinity, including 0. Your x-intercept, since it touches the origin, it goes through the origin. Your x-intercept and your y-intercept will both be at 0, 0. If you look at the graph, there aren't any curves that are leveling. There's no jumps in the graph. So therefore, this graph does not have any asymptotes. If you go to the top of the graph, it doesn't stop. So there is no maximum. But there is a minimum. So if you look, this is the lowest part, So your minimum is going to be 0, 0, or y is equal to 0. And because the y-axis divides this into 2 equal parts, then we're dealing with a reflectional symmetry. And that is quadratics. The inverse of a quadratic is going to be a square root. Well, actually, let me see. Only part of it is an inverse, not the whole thing. Okay, so the positive square root of x will be the inverse. And the last, function is square root. Y equals the square root of x is the actual parent function equation. If you look at the graph, I call it like a baby heel. It looks like a little heel. But this graph doesn't have an actual name, so you just have to recognize the shape and come up with an association for yourself. Okay. If I look at this graph, the domain is left to right. So my left would be starting at 0. and my right would continue. So my domain is from 0 to infinity. Come on, work with me, pen. Including 0. And then your range is going to be your lowest to your highest. So the lowest the graph goes is 0, but the highest, there isn't a high because, again, it continues. So your range is also 0 to infinity, including 0. All right, when we look at the x-intercepts, again, it goes through the origin. Not on all these, but a lot of these, your x-intercepts and y-intercepts are kind of at the origin, so they'll be the same. This graph looks like it's leveling off, but it really isn't. It's just slowly increasing. So this does not have an asymptote. Because it's continually increasing, there isn't a maximum, but there is a minimum. So this graph is not going to go below 0. So your minimum is going to be at 0, 0, or y is equal to 0. Okay, when you look at this graph, the y-axis is not a mirror. There's no reflection, and there isn't any rotational symmetry. So this actually doesn't have a symmetry. And the inverse function for a square root is going to be a quadratic. So y equals x squared. Okay, and that is the first parent functions. So those are the first 4 families and the parents of those first 4 families. So hopefully this was helpful. All right, you guys have a good one.